Hello, this is Professor Neshaba, and I'm here to help you out with part 3 of the computational guided inquiry for PCAM inferring model parameters from gas compressibility. So what you've accomplished up till now is that you've got an isotherm, the compressibility Z, as a function of the mole density, and now what we want to do is see if we can create a graph of this and fit it to a polynomial. And so that's what we're up to. Now I'm going to go over to the template that you got for this. And what I've supplied you with is an example of how to do line fitting in Python, in NumPy. And what you'll end up doing is replacing this line right here. Instead of saying what I have here, you'll end up putting something like Z grid of row and then row grid of row, and so on. But for right now, I just want to kind of show you how it works. So we can kind of think of this first variable, row slice, as being the independent variable x, let's say, and I've, in other words, said that goes from 0, 1, 2, 3, 4, 5. And now also just to give you the example, I've said z is just the exponent function, just e to the x. And what we're going to do is see how well a third order polynomial does in approximating that exponential function. So how do we do that? Well, that's all in this thing called pfit. So kind of working this back from the inside out, the first part of pfit says polyfit. And the syntax here goes, give polyfit your x variable, and then give it your y variable, and also tell it 3, which means that we went up to an x cubed term in the polynomial. This flip up down, what that does is it makes when the vector is returned of all these coefficients that are going to be in pfit. What this does is it says put the 0th order term in the 0th entry of that array, and then and so on. So this would be the 0th order term, first order, second order, and third order. And just for convenience, I've printed these all out. Okay, and this kind of the next line here says, well, what does that correspond to as a polynomial per se? Well, I know how to construct a polynomial. I take the 0th order term and take the first order term and multiply it by x, and then third term by x squared, and so forth, x cubed, and then we're going to make a graph of it. Now in this case, the next new thing for you is that the plot command, we've actually given it 2 things to plot. Okay, the first one is like our experimental data, which I want to have just a symbol for, and then the second one is, it's the same independent variables, but now we're, instead of giving our experimental z values, we're going to give what was generated by this command right here, which is the polynomial fit. And so let's just see how that works. Hopefully it'll all be just fine. And so what are we looking at here? Well, this is the experimental numbers. That is to say, this is the exponential function. And then this green line here is the best fit polynomial approximation to that. So again, what you'll be doing is replacing row slice with with your isotherm, and z slice with your z isotherm, and I think pretty much the rest of this will look very similar.